Good morning, students. Our new topic in the topic of metals is reactivity series. So today we are going to read different concepts of reactivity series. A lot of concepts are going to be involved. So concentrate yourself. We are going to start now. So the reactivity series is widely used in order to. So here are four important functions of the reactivity series. Number one, it explains the stability of the compounds when heated. Number two, reactivity series explain the method used to extract a metal from its ore. Number three, reactivity series explain the corrosion of the certain metals. And number four, the reactivity series predict possible reactions involving metals. The position of the various metals in the reactivity series electrochemical series are shown below. So this is the reactivity series. So from bottom we are going to read silver, copper, lead, iron, zinc, aluminium, magnesium, calcium, sodium and potassium. So as we go from lower to upper in the reactivity series, the reactivity increases, lose electrons more readily because metals in the top are more reactive, so they are ready to lose their electrons, form positive ions more readily. So when they lose electrons, they form positive ions. And stronger reducing agents. So as we go from bottom to top, these are the special qualities which will matter. Knowing the position of a metal in the reactivity series enable us to predict how it reacts. So look now, these are the top metals, these are the bottom metals. So actually we are going from bottom to top, from right to left. So the metals are going to react with a dilute hydrochloric acid. So from here you can see copper is not reacting with dilute hydrochloric acid. Lead is reacting with dilute hydrochloric acid very slowly. You can see a very few bubbles. Tin is reacting with dilute hydrochloric acid faster than the lead. Iron more faster, zinc even more faster, and magnesium the fastest out of these metals. Table below shows the reactivity of the metals with water and dilute hydrochloric acid. So here are the metals. These are three topmost metals: sodium, potassium and calcium. And now first we are going to read its reaction with water and then dilute ACl. So because they are very reactive metals, they even react with cold water. Alkali and hydrogen are formed. Reactivity decreases down this series. So as we go from top to bottom, the reactivity of the metals decreases. These metals react with a dilute ACl violently because these are very reactive metals. Salt and hydrogen are formed. Reactivity series decreases down this series. Okay, the next three metals after these three metals are magnesium, aluminium and zinc. They react with steam because they are less reactive than these three metals. So that's why they are not able to react with cold water. They react with steam. Oxide and hydrogen are formed. Reactivity decreases down this series. And when these three metals react with dilute ACl, they react rapidly, not violently. Salt and hydrogen are formed. Reactivity decreases down this series. After these three metals, as we go from top to bottom, iron comes. So now we are going to read the iron's reaction with water and dilute ACl. Iron reacts reversibly with steam. Iron oxide and hydrogen are formed. When iron reacts with dilute ACl, it reacts slowly because this metal is even lesser reactive than these three metals. These are most reactive metals, these are lesser, and this is even lesser. So it reacts slowly with dilute ACl. Salt and hydrogen are formed. Okay, we are even going more lower, then lead comes. So this no reaction with the water or steam because this is even less reactive. Lead reacts with dilute ACl, it reacts slowly. Salt and hydrogen are formed. Reaction stops due to formation of the insoluble lead chloride. And in the bottom of the reactivity series, we found copper and silver. So they do not react with the water or steam. And this do not react with even dilute ACl. So no reaction is there. So because in the bottom, the metals are very less reactive. In the reaction between the metal and water, the metal atoms displaces hydrogen atoms from water molecule to form metal oxide and hydrogen. So look now, metal and water when react with each other, metal oxide and hydrogen is formed. If the metal oxide is soluble in water, an alkaline solution is formed. So this metal oxide when dissolved in water, if it is soluble, then alkali is formed. An example is here. 2Na plus 2H2O forms 2NaOH plus H2. In the reaction between a metal and a dilute hydrochloric acid, the metal gives away its valence electron to hydrogen ion to form hydrogen gas. So first, metal and hydrogen ion when react with each other, so the metal will give its valence electron to hydrogen ion. So the hydrogen ion will become hydrogen gas. So look now, and this will become metal ion. The metal ion then combines with the chloride ion to form a metal chloride. And you can see metal ion is reacting with a chloride ion to become a metal chloride. And here is the overall reaction. Mg plus 2ACl forms MgCl2 plus H2. Although aluminium is quite a reactive metal, it reacts slowly with dilute hydrochloric acid. So this is the exception. Although aluminium is very reactive metal, but it reacts with dilute ACl very slowly. The reason is actually it is protected by a thin and tough layer of aluminium oxide on the surface of the metal. So this is the reason why aluminium, although it is very reactive metal, but even then it reacts with dilute ACl very slowly. The oxide layer on the aluminium can be made thicker by a process called anodizing. Reactions of the metal oxides with carbon and hydrogen. So here you can see, here are the metals and reduction of the metal oxide with hydrogen. Then in the next column, reduction of the metal oxide with carbon. And in the next column, action of the heat on metal carbonates. So these are the metals which are on the top of the reactivity series. You can see potassium and sodium. So look now, potassium and sodium are at the top of the reactivity series. and then we will go down. But in this case, when reduction is involved, something different will happen. So concentrate yourself. So potassium and sodium, reduction of the metal oxide with hydrogen. Metal oxides cannot be reduced by hydrogen. Cannot be reduced. So something different is going to happen. So you have to concentrate now. These metals do not reduce of the metal oxide with carbon. Metal oxides cannot be reduced by carbon. So potassium oxide and sodium oxide cannot be reduced by carbon. And these metals cannot be decomposed because of the action of the heat on the metal carbonates. So potassium carbonate and sodium carbonate cannot be decomposed by the action of the heat. Next three metals, calcium, magnesium, and aluminium. Metal oxides cannot be reduced by the hydrogen. Metal oxides cannot be reduced by the carbon even. And metal carbonates are decomposed to form metal oxide and carbon dioxide. So these three metals, metal carbonates, can be decomposed to form metal oxide and carbon dioxide, decomposed with increasing ease down this series. So this is the difference, increasing ease down this series. So as you go down this series, the reactivity will be increased now. So the next metal is zinc. Metal oxides cannot be reduced by hydrogen. Metal oxides are reduced to metal and carbon dioxide. So look now, this is going to be reduced when react with carbon, reducing with increasing ease down this series. And zinc carbonate are decomposed to form metal oxides and carbon dioxide, decomposed with increasing ease down this series. Next, we are going to read iron, lead, and copper. Metal oxides reduce to form metal and water. So look now, they are going to reduce now at this stage. Reduced with increasing ease down this series. These metal oxides are reduced to metal and carbon dioxide, reducing with increasing ease down this series. And these metal carbonates are decomposed to form metal oxide and carbon dioxide, decomposed with increasing ease down this series. The next, we are going to read the metal silver. Silver oxide reduced to form metal and water and reduced with increasing ease down this series. Silver oxide are reduced to metal and carbon dioxide and reducing with increasing ease down this series. And iron carbonates are decomposed to form metal, oxygen, and carbon dioxide. So look now, these are even decomposed more clearly. So they are decomposed to metal, oxygen, and carbon dioxide. The position of the carbon and hydrogen in the reactivity series are shown below. So this is the reactivity series when we put carbon and hydrogen in it, and this new reactivity series will help you a lot in solving different types of equations. So look now, after aluminium, carbon will be introduced, and after zinc, hydrogen will be introduced. So as you go from bottom to top, reactivity increases, stronger reducing agents. The next thing in the lecture is displacement reactions of metals. So concentrate yourself, a more reactive metal is able to displace, kicked out, a less reactive metal from its compounds. That is, a metal higher up the reactivity series can displace a metal lower down this series. So you can see here a cartoon. A competition is going on between copper and iron. The more reactive metal has a higher tendency to lose electrons and form positive ions. A more reactive metal can displace a less reactive metal from its solution. So here you can see iron will win and copper will lose because iron is higher up in the reactivity series than copper. So iron is the winner. Magnesium is more reactive than copper. It is higher up the reactivity series. Therefore, magnesium displaces copper from the solution. So, when magnesium will react with copper sulfate, because magnesium is higher up the series than copper, so it will displace copper from the compound and will take its place, and magnesium sulfate will be formed and copper will be kicked out. So here you can see magnesium is going to be put into the copper sulfate solution. So copper will be kicked out and magnesium sulfate will be formed. Zinc is more reactive than lead. It is higher up the reactivity series. Therefore, zinc displaces lead from the solution. So here you can see zinc is going to be reacted with lead nitrate. So lead lower down this series. So that's why it will be kicked out and zinc will take its place and zinc nitrate will be formed. The next thing that we are going to read is the reduction of the metal oxides by a more reactive metal. A more reactive metal is able to remove oxygen from the oxide of a less reactive metal. The more reactive metal loses electrons more readily to form positive ions. The example below shows the reduction of the zinc oxide by magnesium. So magnesium is up the series than zinc. So zinc will be kicked out and magnesium will take its place and it will form magnesium oxide and zinc is kicked out. Magnesium reduces zinc oxide to zinc. A magnesium atom loses 2 electrons to become Mg2 plus ion, which then combines with the oxide ion to form magnesium oxide. So here is a cartoon that shows the whole story. A competition is going on between magnesium and zinc for capturing O. And in the end, magnesium will win because it is higher up the series and it is having higher tendency to lose its electrons to become positive ion. So when it will react with oxide ion, it will form magnesium oxide. So magnesium is winner, zinc is loser. This reaction can be used to determine the order of the reactivity of the given number of the metals. Example is here. Various mixtures of a metal and the oxide of another metal were heated. Use the experimental results shown below to determine the order of the reactivity of the metal X, Y, and Z. So here you can see, here is a table. When metal X and Y react, when metal X react with oxide of Y, observation, mixture glows, gray solids. So if the mixture glows, it means a reaction has occurred. So it means metal X is more reactive than Y. And when metal X react with the oxide of the Z metal, so mixture glows brightly. So it means again reaction will be occurred. So it means X is even more reactive than Z. And when metal Y react with the oxide of the Z, mixture glows slowly. pink solid is formed, it means again reaction has been occurred. So it means Y is more reactive than Z. And so from the table you can see it means X is the most reactive, then Y, and finally Z. So you can see here, hence the order of decreasing reactivity of the metals is X is more reactive than Y and Y is more reactive than Z. So this is the decreasing reactivity order. Here is our exam tip. More reactive metals are stronger reducing agents and weaker oxidizing agents. The fact that more reactive metals are able to give valence electrons away more readily makes them better reducing agents and they undergo chemical bonding more readily. Hence, pure metals that are more reactive tend to displace less reactive metals from their salts or oxides. So this is the reason, because they have the high tendency to lose valence electrons, so they kicked out the less reactive metal from their salts or oxides. The next thing that we are going to read in the lecture is thermal decomposition of the metal carbonates. Most metal carbonates decompose when heated to form a metal oxide and liberate carbon dioxide. And here is the general reaction. Metal oxides, when decomposed, it forms metal oxide and carbon dioxide. An example is here, copper carbonate when decomposed. So copper oxide and carbon dioxide will be formed. Point to be noted, sodium carbonate and potassium carbonate are very stable to heat. They do not decompose. They are not decomposed on heating. Table below shows how the thermal stability of the various metal carbonates changes down the reactivity series. So, potassium and sodium, the action of the heat on the carbonates, no decomposition. They are not decomposed because of the heat. Calcium, magnesium, aluminium, zinc, iron, lead, and copper, they decompose to form metal oxides and carbon dioxide. Decompose with increasing ease down the series, thermal stability of the carbonates decreases down this series. So the topmost do not decompose. The next one, these metals, they decompose to form metal oxides and carbon dioxide. So the thermal stability of the carbonates decreases down this series. And at the end, silver decomposed to form metal, oxygen, and carbon dioxide. So this is even easily decomposed because of the action of the heat. And finally, we are going to read a very important table that actually precises the whole lecture. So look now. Action of cold air on potassium and sodium rapidly attacked. On calcium, this is attacked. So the reactivity goes less down this series. Then magnesium, aluminium, and zinc, little action, protective oxide coating formed. Then iron, rust in moist air. And then lead and copper, little action. Next, we are going to read the action of the water on potassium and sodium, violent in cold. On calcium, attacked in cold. On magnesium, aluminium, and zinc, and iron, react with steam. And lead and copper, no reaction of the action of the water on lead and copper. Next thing that we are going to read the action of the dilute hydrochloric acid and sulfuric acid on potassium and sodium. They explode. Then calcium, magnesium, aluminium, zinc, and iron. They give hydrogen with decreasing vigor as series is descendant. So as you go down this series, the reactivity will be decreased. And finally, lead and copper, there will be no reaction with the dilutes hydrochloric acid and sulfuric acid on these two metals. Next thing that we are going to read is the reduction of the oxides. So potassium, sodium, calcium, magnesium, aluminium, and zinc not reduced by carbon or hydrogen. Then iron, then zinc reduced by hot carbon. Then iron, lead, and copper reduced by hot carbon or hydrogen. Next, we are going to read the nature of the hydroxide. So potassium and sodium, they are strongly basic, stable to heat. And all the other metals in the reactivity series down the potassium and sodium, they are weakly basic or amphoteric. On heating, give oxide and water with increasing ease as series is descended. Next thing that we are going to read is the effect of the heat on carbonates. Potassium and sodium are very stable, and all the other metals give oxide and carbon dioxide with increasing ease as series is descended. And finally, we are going to read the effect of the heat on nitrates. So for potassium and sodium, give nitrites and oxygen. And all the other metals give oxide, nitrogen dioxide, and oxygen with increasing ease as series is descended. So this was the lecture, students. Read this lecture again very carefully, understand it, and learn it, and make your notes. Thank you so much.